Hello everybody and welcome back. Root Beer here looking at question number 2 on our 2018 Manitoba Math Contest. So we've got two parts just like in one. And so A, solve for x. And we've got x times the square root of x plus 5 times the square root of x plus 5 is equal to 8. Okay, there's a lot of x's and 5's. I'm noticing that I've got the same factor here. So I'm going to write down my expression. And I'm going to factor in x plus 5 on the left side. And that'll leave me with an x plus 5. Okay, so, well, what have we got here? I've got the square root of x plus 5 and then x plus 5. Well, that's just the square root of x plus 5 times the square root of x plus 5 squared. Right? But then the whole thing is x plus 5 to the power 3. And, oh, I know 8. 8 is 2 to the power 3. So if we cube root both sides, we'll get the square root of x plus 5 is equal to 2. And if you square both sides, x plus 5 is going to be equal to 4. X is minus 1. And if you want to, you can plug it back in and double check that sort of a thing. Minus 1 times the square root of 4 plus 5 times the square root of 4 is going to be minus 2 plus 10, and that absolutely is 8. So our final answer for x is going to be minus 1. And that's all there is to it. Okay, now B part. Solve for A and B. Okay, so two equations, two unknowns. In principle, I should be able to solve this. And as I'm looking at it, I see A and B. I'm also seeing square roots. Now, because I just did question 2, I might be thinking about squares and square roots. And because we did question 1, assuming you go through the question or the contest questions one at a time, you'll know we use difference of squares in 1B. And so I'm starting to think difference of squares right away. So we'll get ourselves a fresh piece of paper. We've got A plus B is 53. And then root A minus root B is, I don't remember what they said, 5. Okay, 5. But, of course, root A plus root B is, oh, wait a minute, this isn't a difference of squares, it's a sum of squares. Oh, rats. Well, that's a shame. Okay, then what could we do? I was so swept up, I did not notice that there wasn't a minus sign, there was a plus sign there. Darn it. Oh. Well, good thing I noticed a little quickly, otherwise we would have wasted a ton of time. Alright, so can't use difference of squares. Let's try and rearrange. Root A is 5 plus root B, because now I can square it and say A is 5 plus root B squared, and that's going to be 25 plus 10 root B plus B. Okay. And we also know A is 53 minus B. So if I add these two expressions, I'll get two A's on the one side. The B's will cancel out. Minus B and a plus B. I'll get 25 plus 53 is 78. Plus 10 root B. Okay, I think we could... Well, first of all, let's divide by 2. 78 divided by 2 is 39. Plus 5 root B. Let's bring everything over to the other side. So A minus 39 is 5 root B. And if I square it again, I'll get A squared minus 78A plus whatever 39 squared is. Now this immediately makes me think that maybe this isn't the best way to go about doing it, because I'm actually going to have to do a side calculation of 39 squared. Okay, and that makes me, just because calculators aren't allowed, this is exactly the sort of thing we should be avoiding. 7 2, and 1, 1. So 1, 2, 1, 5. Okay, yeah, I believe that, because 40 squared would be 1600. So, okay. So plus 1521 is equal to 25b. And I guess this could get me to solve for b, and then I'd get a big quadratic in terms of a. So certainly possible. Although, let's not erase it, but I think we could probably try a different approach. I shouldn't be fretting too much. It's a question number 2. So it's weird for it to take me this long, but that's okay. Let's square both sides of the second equation. So let's say 1, 2, 2 squared. You're going to have equal 25 over here. Root a squared is a. You'll get a plus b. You'll get a minus 2 root ab. There we go. This is much better, because now I can do equation 1 minus equation 2 squared, and on the left-hand side, we're going to get 2 root ab, and that's going to be 28. So root AB is 14. AB is going to be 14. Excuse me. 14 squared. I got the hiccups or something. 14 squared is going to be 196. And then, so we'll call that equation 3. Using 1 and 3, we should be able to solve for B. So really, we're looking for 2 numbers that multiply to 196 and add to 53. I can't think of those off the top of my head, but let's move to the next page and say something like B is 53 minus A. So A times 53 minus A is equal to 196. So we'll get 0 is equal to 196 minus 53A plus A squared. Well, really, we could take a look at the factors. 196 is going to be 2 squared, 7 squared. Oh, 4 and 49 will work. There we go. And they're both squares, so that's good. So this is going to be A minus 49, A minus 4. So we'll say either A equals 49, B equals 4, or A equals 4, B equals 49. But we can actually figure out which one it is, because we also need to satisfy 2, and that's root A minus root B is equal to 5. And this tells us root A must be greater than root B, so A must be greater than B. So A is 49, B is 4. Okay. And we probably would have gotten a similar quadratic over here on this side, but using that stuff and plugging it back in somewhere, probably here. But you know, it's important to be able to recognize, hey, this isn't working, or hey, the numbers are too big and I don't have a calculator, or hey, I'm venturing into territory involving theory that I don't quite remember. Can I think of a different way to do it? And there's no shame in ever doing that, even if it's on question number 1 on a I don't know, a grade 7 Gauss or something. What matters is getting the right answer, and above all, because these are math contests, enjoying yourself. But there we go. We've got A and B. We know exactly what they need to be. So onwards to question number 3, and we'll take a look at that in the next video. Thanks for watching.